6.4 Comparing linear and nonlinear functions. Our key vocabulary is nonlinear function. This means does not have a constant rate of change. This is referring to the slope. It is also not a line. Sorry, not a straight line. So example 1, identifying functions from tables. Does the table represent a linear or nonlinear function and explain? So for letter A, we're going to go and find the differences from 3 to 6, which is adding 3, 6 to 9 is adding 3, and 9 to 12 is adding 3. So far this is a linear function because it has a constant rate of change. So this means that, this is change in x values. Then I go from 40 to 32, so that's subtracting 8, 32 to 24, subtracting 8, 24 to 16, subtracting 8. So that's your change in y values. So change in y is -8, change in x is 3. So that means that you can have a slope of change in y divided by your change in x, which is -8 divided by 3. So that means that your slope is -8/3. In order for this to be linear, it has to have a constant rate of change, which it does, with a slope of -8/3. Letter B. Going and finding my x values, to get from 1 to 3, I add 2. 2 to 5, I add 2. 5 to 7, I add 2. So far this is linear because it has a change in x values of 2. My y values go from 2 to 11, so I'm adding 9. 11 to 33, I add 22. 33 to 88, I add 55. This does not have a constant rate of change. Adding 9, adding 22, and adding 55 are not the same values. So this means this is non-linear. There is no constant rate of change. So you can make constant rate of change shortened to crack, but we'll always say constant rate of change. For letter A, I also need to go in there and say that this is linear. Example 2, identifying functions from graphs. Does the graph represent a linear or nonlinear function, and explain? Well, letter C is nonlinear because the graph is not a straight line. Letter D, this is linear because it is a straight line. I did not highlight it very straight, but yes, that is a straight line. So if I highlight it, that is a straight line across. So this is linear because the graph is a straight line. All right, so I want to try these on your own problems. Does the table or graph represent a linear or nonlinear function, and explain? So we're going to start with letter E. 0 to 7, I'm adding 7. 7 to 14, I'm adding 7. 14 to 21, I'm adding 7. So my change in x values equals 7. My y values, each time, 25 to 20, I'm subtracting 5. 20 to 15, I'm subtracting 5. 15 to 10, I'm subtracting 5. So my change in y values is -5. So this has a slope, change in y divided by change in x, of a negative 5/7. So this is linear because it has a constant rate of change. Letter F. Let's find the differences in x. So from 2 to 4, add 2. From 4 to 6, add 2. From 6 to 8, we add 2. So this is the change in x being 2. Then y, we go from 8 to 4, so that's subtracting 4. 4 to 0, subtracting 4. 4 to negative 4, subtracting 4. So the change in y values is negative 4. So I can make a slope again, change in y divided by change in x, of negative 4 divided by 2, which is negative 2. So this is linear because it has a constant rate of change. Letter G. If you look at the graph, these are not straight lines. They are two different straight lines, but it's not one single straight line. So this is nonlinear because it is not a straight line. So example 3 of identifying a nonlinear function is by looking at graphs. By looking at equations. So if it is linear, it's written in the form y equals mx plus b. Nonlinear examples are anything where the variable's in the denominator, so y equals 4 divided by x, or there's an exponent. So y equals x squared. So for letter A, y equals 4.7, or y equals 4 and 7/10. Well, if I put it as y equals mx plus b, this is y equals 4 and 7/10. So technically that would be 0x plus 4.7. So this is linear. Letter B, y equals mx plus b. So y equals pi x. So it's saying the slope is pi. Your y-intercept is 0, so this is also going to be linear. Letter C, y equals 4 divided by x. Well, this one is going to be nonlinear because you cannot write it in slope-intercept form. Letter D, y equals 4 times the quantity x minus 1. So y equals 4 times the quantity x plus negative 1. And distribute the 4 to both terms. Y equals 4x plus negative 4. Y equals 4x minus 4. Because I can write it in slope-intercept form, that makes this linear. So doing a real-life application. Account A earns simple interest. Account B earns compounded interest. The table shows the balance for 5 years. This data has also been graphed. Compare the graphs. So scrolling down, years are 0 through 5. And then account A starts from 100 and ends at 150. Account B starts at 100 and ends at 161.05, or $161.05. So if we notice and we look at the graphs, account A, which is the blue line, increases by a constant rate of change and is considered to be linear because it is a straight line. While account B is nonlinear because it is not a straight line. It is not increasing by the same amount every year. So account A is linear because it is a straight line and has a constant rate of change. Now for that, you can look over at the table. Each time they're adding 10. Account B is nonlinear because it is not a straight line and does not have a constant rate of change.